Prerequisite skills for pre-calculus. Skill number 3B. Range, the one-parent case. Finding range with one-parent function can be done by first identifying the range of the parent, identifying the transformations performed on that parent to obtain the function you have, and then performing all of the vertical transformations on the range. The result is the range of the function. Let's consider some examples. The function g of x has a range of -4 non-inclusive to 12 inclusive. Find the range of the function f of x, where f of x equals -1/2 times g of 7x plus 9 plus 5. In this case, we are given the range of the parent function g. Next, we must identify the transformations that have been performed on g to obtain f. So the vertical transformations in this case are a vertical shrink by 1/2, a reflection in the x-axis, and a translation up 5 units. We begin with our domain of -4 to 12, where -4 is not included, but 12 is. Shrinking by 1/2, this would become -2 non-inclusive to 6 inclusive. Next, the reflection of the x-axis, which is as simple as multiplying the result of the previous step by -1. In this case, this causes us to reverse the terms, so now it is -6 inclusive to 2 non-inclusive. Lastly, we apply the translation up 5 by adding 5 to each of the values in this interval. In this case, we obtain -1 inclusive to 7 non-inclusive. Therefore, the range of f of x is -1 non-inclusive, or -1 inclusive to 7 non-inclusive. If m of x equals -5 times the sine of 2x minus pi minus 3, we'd like to find the range. In this case, the parent function is y equals sine of x, whose range is -1 inclusive to 1 inclusive. The vertical transformations in this case are a vertical stretch of magnitude 5, a reflection over the x-axis, and a translation down 3 units. Again, starting with the range of the parent function, -1 to 1, the vertical stretch causes us to multiply that range by 5, making it -5 inclusive to 5 inclusive. Next, the reflection over the x-axis means multiplying that range by a -1. In this case, it appears that nothing has changed, but truthfully, the 5 became a -5, and the -5 became a +5. Next, we do the vertical translation down 3 units by subtracting 3 from each of those values. So now we have -8 inclusive to 2 inclusive. Since we performed all of the vertical transformations, we can now say that the range of m of x is -8 inclusive to 2 inclusive. Let's consider one final example. Let g of x be 2 times the greatest integer function of 3x minus 15 plus 1/2. Our parent function is the greatest integer function, which has a range of integers. Our vertical transformations are a vertical stretch of magnitude 2 and a translation up by 1/2. Since our parent function has a range of integers, vertically stretching by 2 would give you 2 times every integer. Symbolically, this is a little strange, so we'll let n be an integer, i.e. an element of the integers. And we can change our previous statement into n by vertical stretch becomes 2n, where n is an element of the integers. Next, we can translate up by 1/2. This makes it 2n plus 1/2. Notice that this bears a nice example of how we can do set builder notation. We have a formula, and we have the condition on that formula. Therefore, we can say our range is the set of 2n plus 1/2 such that n is an integer. Or, simplifying that into a rational expression, the set of 4n plus 1 over 2 such that n is an integer.